Hello, today charging a battery, this lead acid battery, from a battery, this lithium iron phosphate battery. Okay, the lithium iron phosphate is 150 watt hours. This little lead acid battery is 12 times 2.3. That's about 30 watt hours. So we've got a lot more energy in the lithium iron phosphate than we have in the lead acid. So how am I going to charge the lead acid battery from the lithium iron phosphate battery? Well, how about we just connect them together, positive to positive, negative to negative. Will this battery charge this battery? Well, not necessarily. Might be the other way around. I mean, it depends which one has the higher voltage. And in fact, the voltages will immediately or fairly quickly become the same. I mean, as soon as you connect the two batteries together, they have to be the same voltage. So there won't be any force, electromotive force, driving energy from one battery to the other. They'll just become the same voltage. There may be a small current for a while, and therefore a small transfer of charge or transfer of energy, but there's nothing to keep driving the process. The other thing, of course, is that if I want to completely charge this battery, its voltage will come up, the voltage of the source battery will go down, and there'll come a point where this one simply isn't more volts than this one. No, simply connecting them together is not going to serve the purpose. So what I need is some sort of engine, some sort of motor that I can pull energy out of one battery and push it into the other one. And I'm going to use this. It is a boost buck converter. First thing it does is boost the input voltage up to a higher voltage, then it bucks it back down to a lower voltage, but this has current control, so it can maintain a constant current flowing from left to right into the destination battery. So let's start hooking it up. I need a negative wire going to here. That goes to the negative of my lithium iron phosphate battery, so I'll plug that in there with the banana plug. Right, positive from the lithium iron phosphate battery to the buck or boost buck converter. But now there's a bit of an issue here. If I plug that in there and then I'm fiddling around trying to connect this and I accidentally short it onto negative, I'm going to melt on my wires. So what do I need? A fuse? Okay, here's a fuse, 5 amp fuse, which I can connect into there. But if I use a fuse and I do this accidental short, at this point where the two connections are quite close together, I'm just going to blow a fuse. And if I keep blowing fuses, that means I need to get new fuses. Now I'm going to use something else. I'm going to use a light bulb. Now it's a big light bulb. This one's an H4 car headlight bulb. I've actually connected it so that the two filaments are in series. So potentially I could put 24 volts across this and it wouldn't blow. But what this is, it's kind of like a fuse, but rather than blow the fuse to tell me that there's been a short problem, it'll just light the bulb. So if I put this in the battery like so, and then I create my short circuit by being rather careless with this wire, all that happens is the bulb lights up. So now I don't need to be really that careful. I just need to connect that into my boost buck converter. And like I say, if there's any short circuit problems here, it just lights the bulb. Okay, so there's my source battery, lithium iron phosphate. I've got my H4 car headlight bulb. And now if I have a short circuit event on the input of this buck boost converter, it just lights the bulb up. So no melted wires, no blown fuses, but the circuit is protected. Right, now I need to put the destination battery, my lead acid battery, on the output of this boost buck converter. But first, a quick look at the topology of boost buck converters to make sure that sticking a battery on the output of the buck part of this converter is not going to be a problem. I'll just sketch this out. Okay, boost converter looks like inductor, diode, and a switch here down to ground. Buck converter is a switch there, a diode down to ground, and an inductor there. So that's the essential parts of the boost and then buck converter. Now the switches also have diodes because they have MOSFET body diodes across them. So we got that one there, and this one which actually points back this way. So we got that diode there. So you can see that what we've got is fairly symmetrical here. We've got inductor going in, inductor coming out. So if there's any problem with sort of power feed into the middle here, we've got two diodes pointing at each other, and so we've really got a safe circuit here. I can put a battery on the input and I can put a battery on the output. Now the only other thing that I should really add to this diagram are capacitors. So we'll have input capacitor, we'll have a capacitor at this midpoint, and there will be output capacitors, and you can see the capacitors on this boost buck converter dotted around. Input capacitor, this is the midpoint capacitor, and a couple of output capacitors. So that's, oh, pen's run out, that's where the capacitors go. So this is equivalent circuit of this thing minus all the control circuitry, of course. So I think we're good to put a battery on the output, and then we can start this thing up and start transferring charge or energy from the source battery to the destination battery. So we need a ground wire for the destination battery. Put that there and attach it to the negative terminal of this lead acid battery. Now I'm going to do the same thing on this battery. I'm going to put a light bulb. I made this PCB so that you can put these H7 light bulbs in parallel. This will go to the battery, and then the other terminal will go to the positive output of this boost buck converter. Okay, attach the positive of the destination battery. Attach the positive of the lead acid battery. Now there will be a small spark, and all that is this battery charging these output capacitors, back charging them through my H7 light bulb, but that's fine. Okay, so everything's set up. Now I'm not expecting these light bulbs to light up unless of course there is a short circuit event. So let's create a short circuit event on the output. That's that bulb lighting up. Short circuit on the input, and that's my H4 light bulb lighting up. Now I can switch on the boost buck converter. I've set it to 13.5 volts. That's a nice float voltage for the lead acid battery, and half an amp, so that's a nice gentle charging current. Let's switch it on. I can see the voltage of the destination battery goes up and settles at 13.5 volts because that's my voltage limit, and the current it's pulling is about 400 milliamps, but that of course will now start to fall as this battery takes in charge or energy and absorbs that energy into its chemical innards. So this current will continue to fall until we've got this battery charged up to 13.5 volts. Now I could take this battery higher, I could take it up to 14 volts, but I'll leave it at 13.5 volts for the moment. And what you can see is that we've just got current flowing from the source battery by virtue of this boost function and then buck function into the destination battery. So what this device is doing is first boosting the input voltage up to a sort of slightly higher intermediate voltage, probably around 15 volts. In fact, we can check that. Okay, so here's the DMM. Let's put negative on there. The boosted positive is on the cathode of this diode, so let's just touch onto there. And yeah, you can see that's at 16.6 volts. So the boost converter first pushes the voltage up to 16.6 volts. The buck converter then brings it back down to whatever the voltage of this battery is. Well, it's actually on voltage limit, so it's on 13.5 volts. That was one of my settings. And with a current that simply holds it at 13.5 volts, which at the moment is 238 milliamps. and that, as I say, will continue to fall. So there we are, we're charging the destination battery from the source battery through these two light bulbs to provide protection, using a boost buck converter as the sort of engine of energy transfer. It's kind of pushing the current from the source battery to the destination battery, transferring energy between the two batteries, and it all works and it's all safe. Cheerio.